In this video, I'm going to go over arithmetic sequences. An arithmetic sequence is similar to a linear equation, except that the domain is only natural numbers. The general term of an arithmetic sequence can be written as a sub n is equal to a sub 1, which is the first term, plus d, which is similar to the slope, times n minus 1. If you want to determine the sum of a finite number of elements in an arithmetic sequence, you can use the formula s sub n is equal to n times a sub 1 plus a sub n over 2. Let's look at an example. If we know that a sub 5 is equal to negative 5 and a sub 21 is equal to negative 45, then what is the value of a sub 35? For this problem, I know I'll need to use the general form for a term in an arithmetic sequence. If I want to find a sub 35, that means I plug in n is equal to 35. But I won't have the value of a sub 35 until I know what a sub 1 is and the value for d. To find this, I'm going to use the 2 points that are given and plug that into the general form. So if I use the term a sub 5, that reduces to a sub 1 plus 4d is equal to negative 5. If I use the information for a sub 21, that tells me that a sub 1 plus 20d is equal to negative 45. And at this point, I have a system of equations that I can solve using any method. You could use the elimination method, the substitution method, you could even use matrices. For this example, I'm going to use the substitution method. I'll start by isolating the a sub 1 in the first equation. To do that, I'll subtract 4d from both sides. That gives me a sub 1 is equal to negative 5 minus 4d. And now I'm going to plug this expression in for the a sub 1 in the second equation. And that gives me negative 5 minus 4d plus 20d is equal to negative 45. And if I combine the like terms, that gives me 16d. To continue solving, I'll go ahead and add 5 to both sides. And then finally divide both sides by 16. Gives me the value of d is equal to negative 5 over 2 after I simplify the fraction. And now the last thing that I need is the value of a sub 1. And I'm just going to go ahead and use the equation where I already isolated a sub 1 and plug in the value of d as negative 5 over 2. So a sub 1 is equal to 5. And now let me plug this into the general form for terms in an arithmetic sequence. That gives me a sub n is equal to 5 plus negative 5 over 2 times n minus 1. And now to find a sub 35, I'll plug in n is equal to 35. And that gives me 5 minus 5 over 2 times 34, which is 5 minus 85. So a sub 35 is equal to negative 80. And for this example, I'd actually like to show you an alternate method. And for this method, we're going to treat d as the slope. And for each term in the arithmetic sequence, I'm going to write that as an ordered pair. So the first one would be 5 comma negative 5, and the second would be 21 comma negative 45. And then to find d, you could use the slope formula, y2 minus y1 over x2 minus x1. And I'm going to label the first ordered pair as x1, y1, and the second ordered pair as x2, y2. Once I plug in all the numbers and simplify, I end up with negative 5 over 2, which is the same answer we got using the previous method. Let's look at another example. Let's say we want to find the sum of 11 plus 13 plus 15 all the way up to 75. For this problem, I'm going to use the sum formula for the arithmetic sequence. And from our original problem, I can see that a sub 1 is equal to 11 and a sub n is equal to 75. We can also find the value for d by finding the common difference from one term to the other in the sequence. In that case, you can see the trend is that you add 2 to each term to get to the next term. So that means our value for d is 2. If I plug that into the general form for terms in an arithmetic sequence, that gives me a sub n is equal to 11 plus 2 times n minus 1. In order to use the sum formula, we're going to need to find the value of n for the term 75 So I'm going to use the general form for terms in an arithmetic sequence and set that equal to 75 and solve for n. Simplifying, that gives us 11 plus 2n minus 2 is equal to 75. Combining the like terms of 11 and negative 2 gives us 2n plus 9 is equal to 75. Subtract 9 from both sides and then divide by 2. We end up with n is equal to 33. And now plugging everything in, we have 33 times 11 plus 75 over 2, which gives us a total of negative 396.